Hello, everyone. Welcome. Good morning, good evening, depending on where you are. We know we have people joining us in South Asia as well as here in North America. I'm Hitesh Hathi. I'm with the Mittal Institute in Cambridge at Harvard University. And I'm delighted to welcome all of you and this distinguished group that you see before you. Count me out of the distinguished, but the rest of them are. And we're here for round two of mapping color in history. It's one of the projects the Mittal Institute is doing. Let me just tell you briefly about the Mittal Institute. We are based at Harvard. Our mission is to connect Harvard and South Asia. And we do that in very rich ways with connections running in all directions, with scholars, faculty, students, projects that range from art and art history, as we are here at the present, to also very extensive projects on healthcare, on climate change, and really a variety of other fields, study of ancient manuscripts to economies today in South Asia. If you are coming to us for the first time, please check us out on our website. Go and subscribe to our newsletter, which gives you weekly news of what we are doing. But right now, back to an event organized by our office in New Delhi. Uh, Mapping color in history. It's one of the most interesting projects, not just at the Mittal Institute, but at Harvard University, which combines multiple fields to look at Indian art in a unique way. And the author of that project and lead researcher is our friend Jinah Kim. Jinah is a very good friend. She leads the art programs at the Mittal Institute. I'm going to throw the podium to her in a second, but let me give a brief introduction. I cannot give a full introduction because that would take the rest of the time we have. So briefly, she's the George P. Bickford Professor of Indian and South Asian Art, Professor of South Asian Studies. Her research and teaching are very wide. They include intertextuality of text-image relationship. And so her work on manuscripts has changed the way we think about manuscripts and the way and the roles they have in South Asia in its civilization. She looks at art and politics, representations of female and patronage, and she's looking at multiple issues relevant today, including reappropriation of sacred objects and post-colonial discourse. Multiple books and articles, I'll just mention a couple of them. Receptacle of the Sacred, Illustrated Manuscripts and the Buddhist Book Cult in South Asia. Garland of Visions, Color, Tantra, and a Material History of Indian Painting. And with that, Jinah, let me throw it to you. Again, welcome everyone. I will go off camera. I am still here, but I want the focus to be on the speakers, and we'll join you again at the end.
Thank you, Hitesh. Thank you, everyone, for joining us. And for those of you who missed the part one, please check out our website and also check out the recording of the event when it becomes available. This session is part two of the Mapping Color in History in Action, or MCH in Action. And Mapping Color in History, as Hitesh introduced, is a digital humanities project that I started to document the published and ongoing pigment research in meteorological institutions to create a searchable database. And we're trying to sort of transform it into a publicly available interdisciplinary research platform. And the MCH is a huge interdisciplinary collaborative project. So it really works with very many different institutions and disciplines, including, of course, art history and curators and conservators and conservation scientists. And of course, the data science and computer engineers are also part of our group. And so to learn more about this project, I hope you will check out our website and also check out our recording that will show you how to use the website. And we will be also sharing a feedback survey form afterwards on the site's usability and functionality. So please help us by filling them out. So I'm delighted to be sort of introducing this morning's session. We have sort of indicated some of the research projects we're doing on Wednesday's session, but today we will have two case studies of ongoing research projects that we're doing. So one will be on the collecting of the pigment samples from India, from Jaipur to be precise. And this is also, I think, a good place to announce a historic collaboration that following the historic collaboration with the Asiatic Society Mumbai that was completed earlier this year, we actually just signed an MOU and begin to will begin our collaboration with the Maharaja Sawai Man Singh Second Museum in Jaipur City Palace. So our mobile heritage lab will be going to, and I think it has just, the equipment just arrived, I was told, in Jaipur. And that's actually also a good place to mention what we're going to talk about today. And so one of the, so there will be two presentations, and let me just introduce our research manager for the arts program for the Mapping Color and History in India. MCH India is what I call it. Anjali Jain, who's our research manager and also independent conservator, and she's the one behind the wheel for all the activities that's happening in India, along with the Mittal Institute Delhi office. And we're really delighted to have Shilpi Guru Babulal Marotia ji, a Jaipur-based, award-winning Jaipur-based miniature artist who won like national award in miniature painting. And Babulal ji हमारे साथ में हैं, बहुत धन्यवाद. And we also have Celia Chari, who's a Beal Family Postdoctoral Fellow at the Straus Center, our analytical lab, Straus Center for Conservation and Technical Studies in Harvard University. And she has a background in material science. And we've been working on several projects together. And one of the projects that we're working together is going to be part of the presentation this morning or this evening. And it is close to publication. And we also have our scientist, Kathy Aramin. I'll give a more proper introduction to her when we're starting her portion of the presentation. So Anjali, can you take over and give us the first presentation on Jaipur pigment collection and how we're collaborating together with Babularji and the scientists at MFA and I'm sorry, at Harvard Art Museums and also MFA actually being consulted. So Anjali, I will hand it over to you. And one thing I'll mention is why we did sort of pigment collecting in the first place is because it's really important to have reference spectra and knowing what is being used on the ground in India today in like traditional painting workshops is very important for us to understand historical pigment usage. So it will be part of the samples that we have collected have been donated to our wonderful forest pigment collection in the Harvard Art Museums. So that's the context of the first presentation. Anjali?
So I'll start with Mr. Babulal Marotia's presentation first.
नमस्कार, मेरा नाम बाबूलाल मारोटिया है, जयपुर का निवासी हूँ, मिनिएचर पेंटिंग बनाता हूँ। 10 वर्ष की आयु से इस कला को पिताजी से सीखना प्रारंभ किया था। जयपुर में एक संस्था थी संग्राम कला संघ, यहाँ पर भी मैंने 7 साल काम किया और मिनिएचर पेंटिंग में जो बारीकियां हैं उसको मैंने सीखा था। मिनिएचर पेंटिंग विभिन्न शैलियों के नाम से जानी जाती है, जैसे जयपुर शैली है। जयपुर शैली मेरी मनपसंद शैली है। जयपुर शैली में अधिकतर मैंने राजा महाराजाओं के, राधा कृष्ण के पेंटिंग बनाए हैं। जयपुर शैली में जो फेस हैं गोल हैं, आंखें छोटी है, इनके जो कद है वो भी छोटे। जयपुर शैली के अलावा मैंने और भी शैलियों में पेंटिंग बनाई है, जैसे मुगल शैली है, किशनगढ़ शैली है, जोधपुर शैली है। मुगल शैली में हम जितना चाहें बारीक काम कर सकते हैं, अच्छी सी बॉर्डर बना सकते हैं। बाकी किशनगढ़ जो शैली है, इसके अंदर पेड़ पौधों का हरियाली का ज्यादा प्रयोग किया जाता है। किशनगढ़ में जो आंख है, फेस है, जो इनके कद है, तीनों ही लंबे होते हैं। इसके विपरीत जो जोधपुर शैली है, इसमें जो बॉर्डर बनाई है, सिर्फ प्लेन बॉर्डर बनाई है, जो लाल रंग है उसका प्रयोग किया जाता है बॉर्डर में। मुगल में जो दाढ़ी आती है वो नीचे की तरफ आई है दाढ़ी। जोधपुर शैली में जो दाढ़ी बनाई है वो दाढ़ी ऊपर की तरफ जाती है। मिनिएचर पेंटिंग बनाने के लिए हम पत्थर, खनिज व पेड़ पौधों से बनाए हुए रंगों का प्रयोग करते हैं। सुनहरे काम के लिए हम असली सोने का वर्क व सोने के वर्क से बनी हुई हिलकारी का हम प्रयोग करते हैं। खड़िया बनाने के लिए हम चकले का प्रयोग करते हैं। खनिज रंग बनाने के लिए हम खलड़ का प्रयोग करते हैं। सोने के वर्क से कलर बनाने के लिए हम थाली का प्रयोग करते हैं। इस कला में काफी बारीकियां हैं, जिसको बनाने के लिए हम बहुत ही बारीक ब्रश को काम में लेते हैं। कुछ वर्षों पहले हम गिलहरी के पूंछ के बालों से बनाई हुई ब्रश को काम में लेते थे, लेकिन कुछ वर्षों से इस ब्रश पे बैन किया हुआ है, तो अभी हम आर्टिफिशियल बालों से बनाई हुई ब्रश का प्रयोग करते हैं। मिनिएचर पेंटिंग बनाने के लिए हम सबसे पहले कागज पर पेंसिल से स्केच करते हैं। कौन सी पेंटिंग बनानी है, कौन सा सब्जेक्ट बनाना है, कौन सी शैली में पेंटिंग बनानी है, इसका हम स्केच करते हैं। जैसे कश्मीरी शॉल और कारपेट की जो पेंटिंग्स है, इसमें काफी बारीकियां हैं। इसमें जो डिजाइन्स है, जब तक वह परफेक्ट नहीं बन जाती डिजाइन, उनमें जो बारीकियां हैं, जब तक हम उसको डिजाइन को अच्छी तरह से नहीं बना लेते हैं, हम उसकी प्रैक्टिस करते रहते हैं। पेंटिंग बनाने के लिए हम हाथ से बना हुआ पेपर काम में लेते हैं, जिसको हम वसली कहते हैं। यह वसली पेंटिंग के साइज के अनुसार 3 पेपर, 4 पेपर या 5 पेपर चिपका कर बनाते हैं। पेपर चिपकाने के लिए हम ल्याई का प्रयोग करते हैं। ल्याई को बनाने के लिए अरारोट या मैदा काम में लेते हैं। सबसे पहले हम वसली पे खड़िया के द्वारा बेस कलर तैयार करते हैं, फिर पेंसिल से उसका स्केच करके ब्राउन कलर से उसको फाइनल आउटलाइन करते हैं। लाइनिंग करने के बाद हम रंग भरना प्रारंभ करते हैं, जिसको हम धरावट बोलते हैं। फिर हम इस पेंटिंग में जो बारीकियां हैं, जो शेडिंग का काम है, डिजाइनिंग का काम है, आउटलाइनिंग का काम है, वो बनाते हैं। पेंटिंग बनाते समय हम पेंटिंग की 3 बार हकीक पत्थर से गुठाई करते हैं। यह गुठाई कांच के ऊपर पेंटिंग को उल्टी रखकर गुठाई की जाती है। इस पेंटिंग में रंग भरे गए हैं, जिसको धरावट बोलते हैं। इस पेंटिंग में शेडिंग, डिजाइनिंग, आउटलाइनिंग का काम किया गया है, जिसको हम खुलाई बोलते हैं। पेंटिंग में सोने से बना कलर, जिसको हीलकारी कहते हैं, अधिक प्रयोग किया गया है। इस तरह मिनिएचर पेंटिंग बनकर तैयार है। यह पेंटिंग राधा किशन डांस देखते हुए बनाई गई है, जो बूंदी शैली में है। यह पेंटिंग मेरे लिए बहुत मायने रखती है, क्योंकि सबसे पहले मुझे इस पेंटिंग पे स्टेट अवार्ड मिला था। पिछले 30 वर्षों में मुझे इस कला में काफी पुरस्कारों से सम्मानित किया जा चुका है। इसके अलावा 30 से अधिक देशों में मेरे द्वारा बनाई गई पेंटिंगों की प्रदर्शनी भी लगाई जा चुकी है। इस कला को विलुप्त होने से बचाने के लिए मैंने 97 में सरस्वती कला केंद्र की स्थापना की और संस्था के माध्यम से प्रतिवर्ष इस कला का प्रशिक्षण दे रहा हूं। पिछले 25 वर्षों से सिटी पैलेस में भी इस कला का प्रशिक्षण दे रहा हूं। अब तक 26,000 से अधिक युवा कलाकारों को इस कला का प्रशिक्षण दिया जा चुका है। मेरे से प्रशिक्षण प्राप्त कर कई युवा कलाकारों को राष्ट्रीय स्तर पर राज्य स्तर पर भी सम्मानित किया जा चुका है। धन्यवाद।
That was amazing. धन्यवाद, बहुत धन्यवाद.
Okay. So, hello everyone. So from the art of miniature painting, let's jump and take a U-turn into the scientific and chemical aspects of it. Colorants can either be dyes or pigments. Dyes are basically soluble in various types of media, whereas pigments are insoluble. Because of being soluble, dyes can be applied onto any kind of substrate by dipping the substrate into a solution or painting the solution onto the substrate, whereas pigments need to be dispersed into a medium and then applied or painted onto a substrate. Few examples of dyes, commonly known dyes, are indigo, madder, and other dyes that are used for textiles, whereas things like vermilion, opiment, and other mineral-based colorants are all pigments. Another type of colorant are basically lake pigments, which are not actually natural. They're made by precipitating a dye on an inert binder, and which is why they may be fugitive, because the actual coloring material in those is actually a dye. So pigment history in Western art has been quite thoroughly researched, which has helped to understand their usage and transport, trade, and history in very much detail. But unfortunately, that's not very extensively studied in the case of South Asian paintings. Professor Kim's book, Garland of Vision, explores this topic and, of course, is a springboard for the whole MCH project, where we try to collect data on pigments used in historic artworks. But we also realized that there might be some value in studying pigments used by living artisans. This was to help not only fill the gap on the studies of pigments, studies characterizing pigments used in South Asia, but it was also thought to help with understanding the sources of these pigments in South Asia and their availability, processing, and use in the paintings. We also thought that this would help to understand the impact of the manufacturing processes on the actual colorants that end up on the miniature paintings. And we also hoped to realize or understand how these traditional pigments and dyes were being replaced by modern synthetic pigment colorants that are becoming available in the market. And lastly, we were really keen on building a vocabulary of local terminologies which are used for these coloring materials, because a lot of the archives might have more research available which actually talk about the original terminologies and not the English terminologies for the pigments. So Mr. Babulal Marotia, who actually has a stall in the Friends of the Museum at the MSMS2 Museum in City Palace, was approached. And after a brief conversation with him, I visited his studio a home studio at Kishanpol Bazaar in Jaipur. 41 pigment samples were collected from his studio in raw as well as comminuted form to understand the effect of that processing that had to understand the effect of the processing on the pigments. So this is a video of the actual Ghutai process, which is basically what comminution is called. So you can see that the raw pigment is pounded on in a stone mortar, and it keeps being ground until it forms a fine powder for a day. On the second day, we start adding water into this to allow wet grinding, which helps to further reduce the particle size of the pigment. And this is again continued for a day. At this stage, we start to see some yellow streaks in this orange pigment, which are more clearly visible here. And when it's left overnight, the yellow starts to coalesce into these globules. On the starting of the third day, gum arabic was added into the pigment mixture and was mixed using the Ghutai procedure. And after that, again, this is continued for many, many days. Every night, a yellow fraction was being decanted away from which was collected at the top. And at the end of a process of 5-6 days, we were left with an orange pigment at the bottom of the mortar, which was collected. And yeah, that was sent for analysis as well. So pigment samples were collected at every stage of this process to help understand how the previous sample differed from the next one through further analysis. Babulalji has also been instrumental in connecting us with other points of reference in Jaipur, such as the Pansari shops, which are actually the source shops for a lot of these traditional pigments. Pansari shops are actually, they basically sell spices and raw materials for Ayurvedic preparations, which is which is an important connection to actually explore in the manufacturing of pigments. He also connected us with some foil and shell gold making families in Jaipur, as well as some indigo making and handmade paper making workshops in Sanganair, which is a small town near Jaipur. So these are connections that we will explore in the coming months to actually understand all the various aspects of miniature paintings. Thank you.
Celia, thank you so much, Anjali.
Good, okay. So continuing from that, I'm going to talk a little bit now about the scientific analyses of the pigments that we collected from the workshop of Mr. Babulal Marotia. So as Anjali mentioned, there was 41 pigments in total. We did receive a description of the pigments and the location, so the source of them from the artist. However, we did use different methods of characterization to be able to fully understand what these pigments were made of and connect this to the origin of manufacturing. There are different techniques that we used, and just to generally describe them, we looked at microstructural analyses. So this is basically taking images at a really small scale, typically in terms of microns. This is 10 by 10 to the minus 6 meters, to give you an idea, using optical microscopy, but also, and for that scale, electron microscopy, and also taking images with an optical microscope. Apart from those photographs, we also carried out elemental analyses to understand what elements are present within these pigments. So for pigments that are rich in arsenic and sulfur, like arsenic sulfides, we'd be able to figure this out using XRF or even EDS, which is a type of spectroscopic energy dispersive spectroscopy technique that can give you information about the elements that are present. And then we can also use different forms of spectroscopy to be able to actually figure out the arrangement of these elements in terms of molecular structures. So there are different forms of arsenic sulfide. We can't really tell them apart with elemental compositions because they all contain arsenic and sulfur. But with techniques like X-ray diffraction and Raman, we can distinguish between different forms to get a more holistic understanding of the structures that are present within our pigment. And I'm not going to go into the details of all the techniques that we used, but I'm mostly going to talk about how we can use this to build a database of different spectra of these pigments that we can then use as part of the Mapping Color and History project to understand what materials would be used by contemporary artists in South Asia, but also have been used traditionally in Indian manuscripts over the past centuries. Here is a color wheel showing just the summary of all of these pigments. And as you can see, the names are shown both in Hindi and also English. This was an important thing that Anjali also mentioned, which is looking back at the vocabulary that is currently being used by artists and also has been historically used, as opposed to just calling pigments in terms of their English vocabulary. We want to be true to the words being used by the artist to not avoid any misinterpretation of the materials that are being used. So for example, orpiment, which is a type of arsenic sulfide that I'll mention later on, is called herital. Hinglu is referring to a type of mercury sulfide. Garu is referring to a type of red ochre, so on and so forth. And as you can see, there's a lot of yellows and oranges and reds. There aren't that many blue pigments that we found from Mr. Maratia's workshop, and that's something that we'll talk about later. So first, I just want to talk about the most traditional pigments that we found. These include the pigments that I mentioned, Hinglu, which is a mercury sulfide. This is a photo of pigment number 1, which is also outlined in the little color wheel. And what it is a specimen. This is a mineral that is recovered from the ground. So not really processed into small particles, just the intact specimen. When we looked at it with SCM EDS, this is a technique that can tell us the elemental composition. We could see that it contains mercury and sulfur, indicative of a mercury sulfide. And with Raman spectroscopy, we could see that this was a close match to cinnabar. So we found 2 versions of Hinglu. The other one was number 8, which you can also find highlighted in the wheel. And that one was actually a pre-processed pigment mixture that contained both vermilion, and also it had the presence of kaolinite. And kaolinite is a white clay. So we have 2 forms. One is the mineral specimen. The other is a pigment mixture of vermilion or cinnabar mixed with kaolinite. Kaolinite itself is also shown and included as its own samples 3 and 4. And as you can see, this clay white mineral is very crumbly in appearance. And looking at it under the electron microscope, you can see that it consists of flakes. These are sheet-like silicates that are composed of aluminum and silicon with traces of other elements. And we could confirm that this was indeed kaolinite with Raman spectroscopy. Oh no, with FTIR spectroscopy. The last traditional pigment that I'm going to mention is orpiment, this arsenic sulfide that is very needle-like in appearance. It actually fractures into sharp little pieces that are can be a little bit better seen in this image with electron microscopy. And they're rich in arsenic and sulfur. And using Raman, we can specifically say that the form of arsenic sulfide that we're seeing is As2S3, this arrangement that we expect for orpiment. There is another form of herital that is included in this collection. And this one is actually a mixture of orpiment with sulfur crystals to give a slightly different hue of yellow. So in all of these cases, we have variations that give either slightly different tones or colors, but that contain the main principal colorants, like orpiment, kaolinite, and mercury sulfide. So these pigments have been found in Indian manuscripts dating back to the 16th century. In this example from the Harvard Art Museums, we can see that the red here is a close match to vermilion and cinnabar, showing that this is a use of a 16th century Hinglu. And the yellows that you can find, and the whites that you can find in the eyes, we can see with X-ray fluorescence that it's rich in aluminum and silicon, indicating that it could be the clay white Korea. We actually took a sample from this white that has flaked off over time, and we looked at it with FTIR to confirm that it was indeed kaolinite, showing that in the 16th century manuscript, we are seeing the use of Korea. And lastly, with the yellow border that we see here, with Raman spectroscopy, we could confirm the use of orbaments. So this is a 16th century use of Heritel. There are some pigments that we looked at from the artist's collection that were different to what the artist originally thought the pigment would be. One example was meal, which he purchased thinking that it was indigo, as that's what it was sold as in the supplier that he went to. This is what the pigment looks like, and you can see that it's blue, looks a little bit light for what indigo would typically appear as. Our analyses showed that the blue was actually Prussian blue. And it wasn't just Prussian blue, it was a mixture of a lot of different pigments. And these included a mixture of calcite, likely added as a white, barium sulfate that could have either been added again as a white pigment or as an extender, quartz, and of course, Prussian blue. Even though this was unexpected, as the artist, and it would have typically been assumed that indigo would be a common pigment in a traditional workshop, the use of Prussian blue isn't that different to what we have seen, at least in historic manuscripts at the Harvard Art Museums. There is one later example that we have in our collection dating back to the 18th and 19th century that does use Prussian blue as the main blue found in this background. So even though this isn't a pigment that we would typically expect in, say, 16th century Indian artworks, it is within the palette that we know later on, closer to the 19th century. So it's not that surprising that we can find that in a workshop that's contemporary. Another variation from the artist's description is seen through Menzel, which Anjali mentioned earlier on through this video step-by-step process of the artist processing it into a fine particle size. So this was thought to be realgar, and it is a type of realgar, but it's not quite the form that we know within the heritage science community as being alpha realgar. It's instead a really rare mineral referred to as benaziite. This is what the pigment looks like in its raw form, and again, here we have the specimen, so before it's processed into fine particle sizes. And with our elemental characterization, we can confirm that it consists of arsenic and sulfur. And with Raman, we can confirm that it's this rare form called benaziite. Benaziite is a funny mineral because it can undergo this alteration, basically a degradation process, when it's exposed to light. This isn't light that's difficult to be exposed to. This is just visible light, sunlight. Once it's exposed to sunlight, it undergoes the step-by-step process where it alters from an orange benaziite to a yellow-colored pararealgar. So these yellow fractions that we're separating out during the process that Anjali was describing is actually because of the light-induced alteration of these fine particles into a yellow. And with every step, you can remove that to finally obtain the orange color of benaziite. So pararealgar itself has been found in a lot of different manuscripts because over time, we can expect that this orange colorant will alter into it. And with this in mind, we have never found benaziite in any of the Indian manuscripts at the Harvard Art Museum's collections. But we have found pararealgar. So in this example from the 16th century, this orange tree trunk does contain pararealgar. This doesn't rule out the fact that Benazzi could have been used as a historic artist material. It just brings up the idea that over time it might have altered. So in this day and age, with the techniques that we have, all that we can detect is the degradation product, and we know that para-realgar is used in this manuscript. We just don't know fully if it was an intentional artist material or if it altered into para-realgar from something like realgar or Benazzi. There were some challenges during this process. I won't be talking about all 41 pigments, but I will mention 2 cases that were a little bit complex. One is pigment number 22, which was also known as Haravata, thought to be green earth. It contained a mixture of different compounds. Some of them were aluminosilicates that we would typically find in green earth. But there was a really high content of zirconium, which was really confusing since this is not something that we would typically find. More than anything, it was confusing because of the structure. The type of zirconium-bearing compound that we were finding was actually cubic zirconia, which is not naturally occurring, and it's hinting to the fact that this was a much more contemporary pigment that contains this synthetic component of cubic zirconia. Our analyses found that because it was yttria stabilized cubic zirconia, which is definitely used in modern day refractories as abrasives, this was likely as a result of procedures that could have been used to prepare the pigment. So for example, ball milling media that might have broken off over time, leaving these big chunks of zirconia within the pigment. That's one thought. But this is still a little bit of a mystery why zirconia in such a large amount was included in Haravata. Another challenge has been in cases where we have organic colorants, being able to accurately identify those colorants. And one example is tilak, that is thought to have been sandalwood. It's interesting because when you look at this pigment and you smell it, it really does smell like sandalwood. But being able to identify the dye required some work. Initially, when we looked at this pigment with FTIR spectroscopy, we could find the carrier of the pigment, so the main organic component that the dye sticks to, and we could see that that was calcite. Being able to look at the dye, though, was pretty difficult without extractions. So to separate the dye from the carrier, we had to use ethanol. And then with that extract, we could carry out FTIR to confirm that one of the components of the dye is actually a synthetic azo dye known as acid orange 7. So we weren't able to definitively say that sandalwood was present, but we can say that this is a more modern day version that also includes additional dyes like azo dye, making this different to what we originally thought it could be, and more of a modern version. So those are the main pigments that I wanted to mention just as a quick little introduction to this study. We are towards the end of the project, and actually we're in the process of answering to some reviewer comments right now for this larger project on the study of Mr. Maratia's pigments. So hopefully in a few months, you'll be able to access it and learn all about the palettes, the palette that we had been studying, and get more information if you're interested in hearing about the scientific details of the process. But yeah, thank you so much for listening, and I'll pass on to Kathy.
All right, so our second, thank you so much, and this was wonderful to see the artists working to pigment collecting to scientific analysis. Thank you all. And so our next speaker is Dr. Kathy Ehrman. She's a Patricia Cornwell Senior Conservation Scientist at the Harvard Art Museum. And she studied natural sciences at the University of Cambridge and received a PhD in metamorphic petrology from the University of Cambridge in 1994. So she's been a really instrumental part of our project from very beginning. So I'm so delighted that Kathy can tell us a little bit more about what we've been finding, share what we've been finding with the work that we are doing with the MCH. Kathy, over to you.
Thank you, Jinah. And hopefully I can share my screen. Fortunately, everything's now disappeared.
We can see your screen.
Yeah, there's
Oh, the slideshow.
yes, I can't get at the slideshow. Hang on, that should work. Thank you, and thank you for that introduction, Jinah. So I'm going to be talking today about some of the ways in which we can use the information in the Mapping Color in History database and the work that we've done, particularly at the Harvard Art Museums. Most of the case studies I'll be talking about come from our collection, to look at how the palette changes in Indian manuscripts. Just to set a bit of the, to give you an introduction to our department, I'm based, as is Celia, at the Straus Center for Conservation and Technical Studies at the Harvard Art Museums. And this, the Conservation Department was founded in 1927 in the Fogg Art Museum, which then later became part of the Harvard Art Museums. I'm showing here a view of the Paper Conservation Lab at the top and the Objects Conservation Lab on the lower right, in the new building, which was renovated in 2014. There are 4 labs: analytical, which is my lab, paper conservation, object conservation, and painting conservation. And the Straus Center has a long history of research on Indian materials. And this began with Rutherford John Gettens, the first scientist at the Fogg Art Museum, who corresponded regularly with Dr. Paramasivan, a scientist at the Madras Government Museum between 1933 and 1936, about conservation treatments of materials and analysis of cultural heritage. And there's an excellent article by Sanchita Balachandran, which I have given a reference to at the bottom here, and I think it will be in the chat, on the history of Dr. Paramasivan and conservation science in India in the early 20th century, which I urge you to look at if you're interested. I'm having problems advancing the slides, actually. As mentioned, the Straus Center also hosts the Forbes Pigment Collection, which is a collection of historic and modern pigments we are still collecting. The earliest samples date back to the early 20th century. They were collected by the second director of the museum, who was instrumental in founding the department and in appointing Gettens as the first chemist in a US art museum. And the Forbes Pigment Collection contains examples of a wide range of pigments from different locations, from different manufacturers, and from different dates. And it's extremely useful as a reference collection, both for us and for other museums and scientists. And the pigments collected by Anjali and worked on by Celia from Mr. Babulal's workshop are now part of the Forbes collection. As Celia mentioned, we have a variety of different techniques that we can use to characterize materials. We use the same ones as she was using for the characterization of the workshop materials, but it is important to stress, so this is divided into elemental and molecular information. It is, however, important to stress that unlike the workshop materials, it's very hard to take samples from these historic manuscripts. In most instances, the analysis has to be in situ and non-destructive with no sampling. And that often limits some of the data that can be collected, and in particular, the certainty about which pigments are present. And if you look at the Mapping Color in History database, you'll see that there are certainty levels for some of these pigments, and that's why sometimes we're not as certain as Celia could be, where she could give full characterization because she had very large samples from the workshop. In rare cases, also mentioned by Celia, we can take tiny samples and use some of these equipments like the Fourier transform, infrared spectroscopy and transmission mode, or the scanning electron microscope that require samples to give full characterization. And this is normally where there's areas of existing damage or loss of pigments. Another technique that we use very widely is imaging. This is used in a variety of museums. I've shown here some of the images we can obtain within the Harvard Art Museums using a video spectral comparator. And you can see here a visible infrared and ultraviolet images of the same area of a late 17th century manuscript. And hopefully it's very apparent, just at a quick view, that things like the greens, there are several different shades of green, and they behave differently in infrared and ultraviolet. Some are opaque, some are transparent to infrared, some fluoresce with this bright yellow color in ultraviolet, some don't. So this gives us an idea of some of the different combinations that might be present, and also how many different shades of a certain pigment we would have to look at. We've also undertaken a lot of collaboration and research, both teaching for classes, generating data for the Mapping Color in History database, and publishing and exhibiting. I've shown on the lower left an example of a publication from the later 20th century produced where there's a catalogue of a collection of artwork from Kota. And this had one of the early essays on pigments and analysis of the materials. And the other images just show myself and Penley Knipe, the head of paper conservation, teaching classes on Indian manuscripts. So with all that in mind, what have we found from looking at the data? Both our own data and that available in the Mapping Color in History database. I should stress that all the comments I'm going to make are based purely on the data we have today. In 20 years' time, maybe even in 5 years' time, what I would say might be very different. There is also perhaps a bias still towards collections from Western art museums, and this is why working with institutions in India is so vital. I've tried to indicate the Hindi names, as Celia and Anjali were stressing. However, of course, this is not necessarily the names that would have been used by the people producing the artworks in historic times. I also couldn't find the names for some of these artworks, so I haven't been able to give them in all cases. And I've shown here some of the pigments from the Forbes collection and also the raw materials, because as Celia stressed, some of these are natural mineral pigments, some like indigo are produced from plants. So we seem to see a division between the pre-Mughal pigments, so those up until about the mid-16th century, and the Mughal and later pigments. Pre-Mughal, it's a fairly limited assemblage. For blues, we have mainly ultramarine and indigo, with rare use of a glassy blue pigment that we'll talk about in a bit. Orpiment, which Celia mentioned, is the dominant yellow with a small amount of yellow ochre. Vermilion or cinnabar, vermilion is the synthetic processed form, cinnabar is the raw mineral, are the main reds, and there is some organic red and red ochre, earth pigments. The whites are very much dominated by white clay with some calcium white like a chalk. And then for greens, there's a limited use of a copper green, but it's mostly a mixture of orpiment and indigo, so a mixture of yellow and blue. And the metallic pigments gold and silver are also used. Moving into the Mughal manuscripts from the mid to late 16th century onwards, we see a real change in particularly the yellows and reds and whites that are being used. Where now orpiment is joined by Indian yellow. Indian yellow was not present in the workshop pigments because although it was an extremely popular pigment, it was outlawed sometime in the early 20th century. But it is this very bright, characteristic yellow. There's also rare use of a lead tin yellow in some of the Mughal manuscripts, and the reds are now joined by red lead. Again, sort of a more orangey red. Lead white becomes the dominant white, at least in the Mughal manuscripts in the database and that we've looked at. And the copper greens expand, particularly with malachite, a copper carbonate, but also with a mixture of other copper greens, which could be either natural minerals or caused by corrosion of something like copper. And I've shown here Indian yellow in its various forms in the Forbes pigment collection, and then some of the greens. So if we look at the earliest of the manuscripts, the Mughal manuscripts analysed at the Harvard Art Museums, this shows a folio from a manuscript of the Hamzanama, dated to about 1570. And we find that the blues and yellows in here are very traditional. We have ultramarine and indigo, and all the yellow is orpiment. However, the lead pigments have joined the assemblage. Red lead is used as a more orangey version, in addition to the more traditional bright red, vermilion, and organic reds. And then lead white is present as the only white. There's extensive use of copper green, probably a copper chloride, but because we couldn't take a sample, we couldn't fully characterize the type of copper chloride. And orpiment and indigo are widely used for these kind of darker, duller greens. And I've shown here just some examples of lead white, which tends to be a synthetic pigment, and then red lead, and you can see its more orangey appearance. The next case study I want to talk about are folios from a manuscript of the Divan of Anbari, created for Emperor Akbar and dated to 1588, the production place being given as Lahore. We have 14 folios in the collection, and this provided a chance to compare the pigments used within the same manuscript. And this was extremely interesting. Some pigments are common within all the folios. So blue, for example, we find ultramarine and indigo being used. All the folios contain a variety of reds. Red lead is always present as the more orangey color, vermilion and organic red as the darker reds. And the only white present is lead white. And you can see in these details on the lower right that this kind of darkens in several folios, for example, in the clothing of the figures. And this is because the lead white, lead carbonate, will react with the environment if there's any sulfur gases present, or you can even oxidize in the presence of oxygen to these sort of black lead compounds. However, there are pigments that vary between the different folios, and critically these are the yellows, where in addition to orpiment, there's also Indian yellow and a rare sort of lighter yellow, lead tin yellow. And lead tin yellow is a lead tin oxide, which is a byproduct of a glass or glazing industry. It was a very common pigment in Europe from the 15th to 17th century. And then there is an expansion of greens with a lot of malachite, and then indigo being mixed with various yellows. So just quickly going through, in 3 of the folios, we found that the only yellow was orpiment. However, 8 of these had the new yellow, Indian yellow, and this was present as the only yellow in 3 examples, but in 5 it actually occurs together with orpiment. And this is quite unusual because previous studies have suggested that you never see orpiment and Indian yellow together. And what we did notice was that Indian yellow was never mixed with indigo to produce a green. It was always orpiment. So perhaps the Indian yellow was too valuable as a new pigment. 3 of them had this lead tin yellow, this new lighter yellow. It's a much lighter shade. And in 2 instances, that was combined with Indian yellow. They were both present in the same manuscript. So there does seem to be a certain amount of experimentation within the Divan of Anbari, using different materials to create different shades and perhaps even different textures. All 3 pigments are used for the clothing, the Indian yellow and orpiment giving a much brighter color, and it's very hard to visually see the difference, but it's very clear in ultraviolet light, fortunately. The lead tin yellow is a much lighter sort of yellow. And then orpiment and lead tin yellow are both used in the greens for vegetation and also as highlights in details on plants and trees, whereas Indian yellow, as I mentioned, is not used for this. So during the 17th century, we see a rapid adoption of Indian yellow, lead white, and red lead within Mughal workshops and some Rajasthani courts, for example, at Bikaner and Bundi. There seems to be much slower adoption of the new pigments in other workshops, for example, at Malwa and Orcha. And an example of this is this folio I've shown here, dated to 1635 from Malwa, where it's a very traditional assemblage. We have the clay white, the orpiment, we have vermilion with no lead pigments, and the greens are indigo and orpiment. So there seems to be a slower adoption in some areas. However, if we look at the development, Indian yellow rapidly replaces orpiment for yellow in nearly all folios. And eventually it does replace orpiment even in the greens. So Indian yellow starts being mixed with indigo instead of orpiment. And you can see this in this detail from our video spectral comparator of the 17th century example from Bundi that I actually showed earlier. If you look at the greens, you can see that they're fluorescing in ultraviolet light. And that shows that these are being mixtures now of indigo with Indian yellow instead of with orpiment. And in fact, there's often malachite mixed in as well. Red lead joins rather than replacing vermilion, organic red, and red ochre. And it's probably because these do have very different hues, whereas Indian yellow is a very similar sort of yellow to orpiment. Red lead is much more orange, so vermilion is retained as one of the bright reds, and red ochre is often more of a kind of a browny red. And lead white largely replaces clay white or calcium white in nearly all of the folios that we've examined or that are in the database. But some pigments were fairly unsuccessful. So lead tin yellow is pretty rare, and it's only really used in the late 16th to mid 17th century. It doesn't seem to have really taken off as a pigment. Maybe this is because it's being imported from Europe and it's scarce. Maybe it's because it's such a light yellow and it's not popular. Or maybe it's just the texture. It's a kind of glassy pigment. Maybe working with it, it was unsuitable for a lot of the uses. And that would be interesting to discuss with some of the traditional artists. We can use the data in the Mapping Colour and History database to try and quantify changes in pigments. So just looking through the data that's available currently in the database, I've tried to kind of count up where we see the different assemblages. So in the whites, you can see that from the 17th century onwards, lead white really dominates and is found in a much higher proportion of manuscripts than any of the other whites. However, there are a significant number of other whites. Tin white, for example, which is a tin oxide, fairly restricted to the early 17th to mid 18th century. And there do also seem to be sort of geographic patterns, which we don't really have time to go into at the moment. There's still some calcium white being used, still some clay white being used, though to a much lesser extent. And this is probably because, if you remember the example Celia showed, the clay white, being a sheet silicate, tends to flake off. It's not nearly, it doesn't bond as well. It's not as retained as well in the manuscript. Zinc white is interesting because it is present fairly sporadically. It's a very scattered distribution, and it may be that some of this is later restoration. We really need to consider the conservation history of some of these artworks to understand how prevalent zinc white is. Indian yellow, as I mentioned, is very dominant in the yellow assemblage, with a small amount of orpiment still being used as yellow. And it would be interesting to assess the geographic patterns in this. Chrome yellow comes in the 19th century. It's a synthetic pigment that's produced in Europe. And I think we'll see a greater proportion in the database as we add more examples of folios created in the 19th and 20th centuries. And then among the blues, I was actually quite surprised to see that indigo appears to dominate, although there is still a significant amount of ultramarine. Smalt, a blue glassy pigment, which was produced in Europe from the 15th to 18th century, is surprisingly common in the database. However, I think this is actually an artifact partly from the analysis that has been undertaken, in that we tend to see smalt in related folios. So where we've analysed 4 folios from the same series, they may all contain smalt. Prussian blue appears in the late 18th to 19th century. And again, Prussian blue is a synthetic blue produced in Germany in the early 18th century, and then obviously has been imported, or even perhaps there is local manufacture by the time we get to the 19th century. The last pigment I wanted to consider is this blue glassy pigment, which is often described as smalt. It's a glass that is coloured with cobalt, and it's extremely easy to detect the cobalt with X-ray fluorescence. It's found in some Jain manuscripts from the late 15th century with ultramarine or indigo. And then it sort of stops being used, and it's next found in Rajput manuscripts from the early 17th to mid 18th century, again, often with indigo. And here I've just shown some details of its use. In the top example from this Jain manuscript at the Museum of Fine Arts in Boston, where the bright blue is the indigo and the sort of more muted grey blue are the smalt highlights. And then in the Rajput manuscript, the face of Krishna has this glassy blue appearance, which you can hopefully see in the detail. Interestingly, chemical analysis suggests that in the case of the early manuscripts, the cobalt may be from Kashan in Iran, and it could in fact be crushed glass or glaze rather than an imported pigment from Europe. We're still looking into this, and it's the characterization is limited by not being able to take larger samples. Which is often the case when working with these manuscripts in the museum collections. However, in the mid-17th to 18th century, the chemical composition matches that very closely of 17th to 18th century European smalt, and it's very likely that this is an imported European pigment. The fact that it stops being used from the mid-18th century is actually consistent with the fact that smalt becomes a lot less popular in Europe at around the same time, with Prussian blue really taking over. So I hope this has given you a rather rapid overview both of some of the work we've been undertaking at the Harvard Art Museums and also of what's possible with the Mapping Color and History database. It provides a very powerful tool for understanding changes in pigment use across time and place. But of course, our understanding is only as good as the data that's in the database. So we definitely need more data to confirm the current hypotheses, particularly from artworks where we have a secure attribution in terms of place and date, and also where we know something about the conservation history. So we can determine whether some of these unusual palettes or anomalies are actually of great interest in terms of pigment use, or could be from conservation or restoration at some point. And in this theme, there are outliers in the database where it'd be interesting to reassess the data, particularly where we have old publication, or in the past where data could only be obtained from limited samples, because there we really want to see how representative that is. And collaborations with institutions within India is crucial. And this is why we're so grateful to the Mittal Institute and to the Mapping Color in History Delhi office, because we do have a slightly Western bias in the works that are present, the works that were collected and are in these art museums. So looking at the materials that remained in India and with a wider spread in terms of geography and cultural style is crucial. Thank you very much. And I look forward to any discussions and questions. I will stop.
Thank you.
Oh, I should just show my acknowledgements to all the people that were involved in this project.
That's right. Well, thank you so much. I realize that we're a little over time,
Yes.
but I thought this was like just amazing to have. Have the artist, Babalarji, to Anjali, the conservator, Celia, and Kathy, the scientist. And this is what I say about Mapping Color and History project as really bridging art and science. And this, I think you saw it in action, that this really does bridge the project in a way, enables bridging the art and science. There are a couple of questions in the chat, so I'm gonna just try to answer 2 questions, possibly. Let's see. This is a question for Chetan Pandey. How do you determine where to take point samples and how many from a representative sample? Is there a standard procedure you follow? I think this is directed to our scientists. Kathy?
There isn't a definite standard, but we use things like the imaging to give us a guide within the manuscript. How many different varieties of red or green or blue do there seem to be present from looking at the visible, the infrared, the ultraviolet? We also use very close examination through the microscope to look at differences between different areas, particularly looking for areas where there might have been some in-painting or restoration. And then we really just start the analysis. So the X-ray fluorescence, because it's non-destructive in situ, we can do a large number of points. And very often I would start doing analysis intending to do a couple of examples of each color maybe. And then I'd find if I was seeing differences between these, I add extra points. So for some of these very complicated manuscripts, we could be looking at 100 points, which is obviously a lot of analysis time. The processing of the data and the interpretation is actually where it takes even more time. And then we would look at the chemical differences from the X-ray fluorescence and determine how much work we would have to do with something like Raman spectroscopy or Fourier transform infrared spectroscopy to really fully characterize the color, the materials that are present. And as I mentioned, there are often limitations because we can't take samples. So sometimes we can't be totally confident. We can just give a suggestion for what the pigment might be.
Well, thank you. So, I mean, I'm just looking at the time, but maybe, and there are quite more questions to answer, but maybe there is a question for while artist is here to answer. Like there is a question about the making of the agar, the preparation of agar, how there is a gum arabic added on the 3rd day, and the material looked very thick, more like honey, the gum arabic itself. Do we know how that binder is prepared? In Western watercolors, the percentage of gum arabic is really low, like 3% in water, as that is enough to get the necessary binding properties. But what was shown in the video seemed like a really thick mixture, concentrated. So is there any other material used as binding medium? Is a question from Clara Granzotto. Anjali, do you want to, can you answer or can you ask Babalarji?
बाबूलाल जी, ये जो गम बनाया था, गोंद जो भी,
हाँ
उसको कैसे बनाते हैं, वो थोड़ा एक्सप्लेन कर गोंद कैसे बनाते हैं आप, कितना गोंद डालते हैं कितने पानी में, आप थोड़ा सा एक्सप्लेन कर दीजिए।
जो गोंद काम में लेते हैं ना, ये बबूल
हाँ,
वाला पेड़ से गोंद काम में लेते हैं। इस
अच्छा
गोंद को खाली हल्के से निवाए पानी में डालना होता है गोंद को।
अच्छा
तो कुछ घंटों बाद वो पूरा लिक्विड हो जाएगा गोंद।
अच्छा।
फिर उसको हम कपड़े से छान के किसी भी बर्तन में या बोतल में उसको रख लेते हैं।
ओके
फिर कलर, जितना कलर के अनुसार, हम जैसे थोड़ा सा कलर है तो 4-5 बूंद डालते हैं। अगर ज्यादा कलर तो उस हिसाब से हम गोंद डाल के फिर उसको, कलर को हम पेपर पे लगा के चेक करते हैं उसको। अगर वो कलर उतर रहा है तो हम उसको थोड़ा सा गोंद और मिलाते हैं। ऐसे पेपर में चेक करना पड़ता है, गोंद सही है तब वो जैसे पेपर पे लगाया हमने, अगर वो कलर नहीं उतर रहा हाथ में तो मतलब वो गोंद सही मिला हुआ है। तो कलर में गोंद अगर कम होता है तब भी खराब है, अगर गोंद ज्यादा भी मिल जाता है ना वो भी खराब होता है पेंटिंग के लिए।
जी, धन्यवाद धन्यवाद।
Anjali, you're
Anjali,
muted.
Sorry. So what he's basically saying is that he leaves the bubble gum particles, or nodules that they get from the market. They leave it in slightly warm water overnight, and then they sort of expand and dissolve into the water solution, which is then filtered out, and they then mix it with the pigment. And then once it's mixed, they try and apply that mixture, a pigment and glue mixture onto the paper, and see whether the pigment is too thick or if it's too powdery. And then basically they adjust the concentration of that binder in the pigment mixture accordingly. Yeah.
Well, so that was a great question and answer, and I think that should be the last question. But there is one question about the what the meaning is of using contemporary artist pigment and like an analysis for historical study. And I would say that we're not identifying these pigments and studying them to project it backwards. It's really, and it's also thinking about the intelligence of tradition, as Molly Aiken put it, that there is this tradition that's actually, really generation to generation handed down, that there is a value in really understanding the process. And the dead artist can't tell us how certain things were made. And so seeing the process and what goes in actually gives an insight to understand the historical processes. So we're not really identifying something that's in 21st century to look at something in the 16th century, but it's a comparison, and through comparison, you're getting insight.
Also, if I can add something just very quickly, with these pigments that we've been collecting, a lot of them are naturally occurring mineral and plant-based pigments from localities that would have been used traditionally. One of the things that we've been doing is actually making paint outs. So painting them out with gum as a binder on paper to create a reference of samples on paper that we can then use for our new analytical techniques as they occur that are non-invasive, that we can then compare to actual artworks. So for example, I've been using Reflectance FTIR. There's very few reference databases on pigments with that technique. Being able to use pigments from Mr. Maratia's workshop that are both contemporary, but also those traditional pigments now opens up a door for being able to look at artworks at the Harvard Art Museums and the MFA and compare it to references. So there's a lot of reasons why it's actually super helpful to look at those pigments and have them in our collection.
Absolutely. Thank you, Celia, for adding that. And I think we will have to close the shop for now. And please stay tuned for more updates from us. We do have social media account, and we will be releasing more news on our publications. And what you saw today will be all in upcoming publications and journal articles and what have you. So stay tuned, and I will hand it over to you, Hitesh. Thank you.
Jinah, thank you very much. Thank you all. What a fascinating, riveting set of presentations. I should complain to you, I was able to do no other work and had to listen to all of them because they're so fascinating. Thank you in the audience, everyone. Please, as Jinah says, stay connected to us and to the project because there's much more coming. Babulal ji, आपकी कलाकारी देखकर और विमर्शन कलाकारी के देखकर बहुत आनंद हुआ, बहुत आभार. I'm saying to Babulal ji,
Thank you.
watching his artistry and his reflection on it was also very powerful. So I'm thanking him also. Thank you all. Good day, good evening, wherever you are. And please join us again for another Mithil Institute event. And Jinah, I cannot give you enough kudos for this extraordinary project and the group of people who've come together for it. So thank you all.
It's all teamwork. It's all about teams. So with that, thank you.
Take care.